Dear students and viewers, very good morning. Let us continue with the last class session on staggered grid and simple algorithm. Just before going to the new one, let us try to summarize or see the topics what we have covered in the last session. Actually, in the last session we are discussing about the importance of staggered grid. In case of general arrangement, there is a main control volume where both the scalar quantities like pressure, temperature and density as well as the vector quantities like u, v and w last vectors have been stored in the center of the cell, namely the P control volume. Okay. If all this both the scalars and the vector quantities have been stored in the same cell node, then it is called as collocated grid. As well as we saw the drawback or the limitation of storing both the scalar and vector quantities in the same cell node. So as well as yesterday we have tried to understand that that any transport equation will be of the form transient plus convection equal to diffusion plus source term. So any term which have a time derivative will be called as transient term. Any term which have the u, v or w or combination of these things will be called as the convection terms. Any term which diffusion coefficient like a mu or k, they are called as the diffusion terms, and the terms namely the rho into fx, the body force term, and the pressure gradient term may be generally summarized as the source terms. So we have discussed about the classification of the transport equation, the various terms involved in the transport equations. So we consider the case of checkerboard arrangement, where in certain case the pressure may vary like this 50, 100, 50, 100, or it may be 500,000, 500,000, or it can be 10, 0, 10, 0 like that. Any value can be there, but it is going to get repeated like black and white, like as in our checkerboard or in the chessboard. So let us, yesterday we have taken a case in which the pressure values at the node WW is 50, whereas the pressure value at the node W is 100. Similarly, the pressure value at node P is 50 and the value of the pressure at node E is 100, which means keep on alternately keep on coming like 50, 100, 50, 100, 50, 100 like this. So let us try to take a case like this and we try to derive the value of minus dou P by dou x, which is existing in the u momentum equation, and we found this value is going to be 0, but the real, hence it is not able to capture the real physics. Here the value should be either minus 50 or plus 50, but we are getting at 0 value, which is not able to capture the real time physics. So how to overcome this? For this only yesterday we discussed about staggering the u control volume and v control volume. So I am going to stagger the u control volume to the right and the v control volume to the top. So whatever we have indicated in the red color striped lines are nothing but the u control volume, and whatever we have given in the green color striped lines are nothing but the v control volume, and here the velocity vectors have been removed little away or staggered from the main control volume. In the main control volume only the scalar quantities like pressure, temperature and densities are stored. So in this way we are able to overcome this checkerboard arrangement, or we will be able to capture the real time physics. So when we are doing like this, so we can see now I have taken the u control volume and not the main control volume or the pressure control volume. Here the here the control volume is the u control volume, where it starts from P and ends at E node, and we have the velocity vector UE. When we are going to do such analysis, we found that the pressure value is not 0, it is either minus 50 or plus 50, like that we are getting, which is we are able to get the real time physics. So that is the advantage of staggered grid. So now to summarize, in case of staggered grid we are having separate control volume for velocity vectors and scalar quantities. Namely, here we have considered the u velocity vector, u control volume and v control volume along with main control volume. That is the advantage of this staggered grid. So coming to simple algorithm, as yesterday we have discussed, we can see this simple algorithm is mainly required for the incompressible flows. It can be extended for compressible flows also, but not required. Generally it is required for the incompressible flows. So the simple algorithm is called as semi-implicit pressure linked equations. So the various assumptions or the various conditions what is required to meet for the simple algorithm are, they should be incompressible flow, and we can extend it to 3-dimensional, where the other algorithm like stream vorticity functions are limited up to only 2-dimension, where the simple algorithm can be extended up to 3-dimensional domain, as well as we can extend this one to the real fluid. So the real fluid is a fluid which has viscosity, and the corresponding momentum equations are known as the Navier-Stokes equation. Whereas if it is going to be ideal fluid, we can still apply this simple algorithm for ideal fluid, but not required. It is more required for a complex flow like real fluid. So yesterday we have seen this continuity equation and 3 momentum equation, and we also seen about the conditions of closures. So here in the continuity equation we have dou rho by dou t plus dou by dou x of rho u plus dou by dou y of rho v plus dou by dou z of rho w equals 0. Similarly we have the u momentum, v momentum and w momentum. So we can see there are 4 equations, there are 4 unknowns. The 4 unknowns are u, v, w and pressure. Here I am not considering the density as a variable, since we are assuming the flow to be incompressible flow where the density is not going to vary, it is going to be constant. So in such a case we can see there are 4 variables u, v, w and p. So we may think there are 4 equations and hence we can solve directly, but it is not so that much easy, because in the momentum equation along with the u, v, w and p there are 4 variables, and in continuity equation also we have u, v, w only, but there is no term with pressure. So it is very difficult to solve, or to make it more precise let us forget about continuity also. Let us take only the momentum equation. In the momentum equation we have 3 equations, 4 unknowns u, v, w and p. So how to solve it? So in order to overcome this problem we are making use of the continuity equation also. We are making use of the continuity equation, and hence now we have 4 equation and 4 unknowns, but still the problem exists. That is how we are going to, because in the continuity equation there is no pressure term. In the momentum equation you have u, v, w and pressure term also. How we are going to link the pressure term which is available in the u momentum equation, v momentum equation and w momentum equation to that of the continuity equation? This method of how we are going to link the pressure to the continuity equation is called as a simple algorithm. So we can see now that 3 terms, the pressure linked equations, we got the meaning of what is meant by the pressure linked equation. So up to this we have covered in the last class. So today let us move further how we are going to arrive at the simple algorithm. That's fine. So let me take a let me take the u control volume. So the u control volume starts from P and it ends at the node E, and in between we have the phase E phase and the corresponding velocity is ue. So this momentum equation, actually the u momentum equation, is similar to that of convection diffusion equation. Along with that we have the transient term, as well as we have the source term, as well as we have this minus dou p by dou x. But the general form is of what? Convection and diffusion. Generally we know the entire momentum equation is comprises of transient plus convection equal to diffusion plus source term. The source term has both body force as well as the pressure gradient term. So what we are going to do means we are going to generally discretize in finite volume method just like for a convection diffusion equation. So generally how we discretize for a convection diffusion equation, it will be like this: AE UE, because I want to find the value of the velocity at the phase E. So my intention is to find the velocity at the phase E. So AE UE will be equal to AE UE plus AP UP. Okay, if it is going to be 1 dimensional. If it is going to be 2 dimensional, it will become A north P north plus AS PS. If it is going to be 2 dimensional. If it is going to be 3 dimensional, then I have to add the other 2 terms also. It will be A T U T plus A B U B plus my source term plus B. Along with the source term, there is one more term called as what? Minus dou p by dou x is also there, that we will discuss and substitute over here. I have to add one more term for the pressure gradient. Okay, so this is a generalized form of the discretized form of the using finite volume method for the u momentum equation, because it reflects a part of the convection diffusion equation. So generally a convection diffusion equation can be represented like this. Okay, so how this can be further simplified? So it is AE UE will be equal to sigma of AN UNB. What is AN, or we can put ANB? ANB is nothing but the coefficients correspond to the neighboring nodes. Here NB indicates neighboring nodes. Neighboring nodes. So ANB UNB. So now sigma means it can be either east and west. Additionally we can also add north and south. Additionally if you want for 3 dimensional we can add top and bottom also. So according to the case this sigma value can be extended for 1D, 2D and 3D. So ANB UNB plus B. So the equation, I will keep this equation as equation number, let us have it as 1 itself. So let us have this equation number 1. This equation I have reduced it to in this simplified form as sigma ANB UNB plus B. This B is nothing but the source term. This B is nothing but the source term. Along with this P, in the U momentum equation we have the term minus dou P by dou X. Minus dou P by dou X. Yesterday itself we derived what is the value of the minus dou P by dou X. Even it's not wrong, we will derive once again so that we will have more familiarity. So but I will make it fast. So it is minus dou P by dou X. Since I am going to apply to this control volume, I am going to apply to this control volume. So it will be triple integral of minus dou P by dou X dx dy dz. So it will become, as I told you yesterday, when I am going to integrate the first derivative, it will become the normal quantity. So it is minus P from the ends, from P to E, from the present node to the eastern node. So the lower limit is P, the upper limit is E, and this dy will become y. When I am going to apply the limits, it will become delta y. Similarly dy z will become z, and when I am going to apply the limits, it will become delta z. So the final form will be what? It will become minus PE minus of minus PP into, this is nothing but what? My area. This area is nothing but the area of this control volume, so I put as AE. So the final form will be PP minus PE of AE, because this minus of minus will become plus, so plus PP minus PE into AE. So this term should be added over here. So as I told you, this discretized form of the U momentum equation will be of the convection diffusion plus source plus the pressure gradient term. Now the result of the pressure gradient term is nothing but what? Plus PP minus PE into AE. So if I am going to write in the second way, it will be plus the same term I have to add. So PP minus PE into AE. So I hope you got it. I will repeat once again. The U momentum equation, which is of the partial derivative form, can be converted into discretized form using finite volume method as a convection diffusion problem. So when I am going to do that, it will become AE UE will be equal to sigma of ANB UNB. So this satisfies the convection diffusion problem with source means plus B. But there is one more term in this U momentum equation, which is nothing but what? Minus dou P by dou X. In the last class we understood how to discretize this minus dou P by dou X, and we arrived at PP minus PE into AE. So this is for the generalized form. This is the way how we can discretize using finite volume method the U momentum equation. In the end of the session also I will try to explain how we have arrived this equation once again, because we have not discussed earlier about the convection diffusion, but nothing to worry. At the end of this today's session I will try to explain how we have landed up here. Right as of now we will go with this one. That's fine. Now instead of E control volume, if I am going to have the W control volume, okay, so let us move to the next slide, and instead of E control volume, if I am going to have the W control volume. So the W control volume will start from W and ends at P, and here it will be W and it will be called as UW. The velocity will be called as UW. Okay, so we can now let us derive what is the value of minus dou P by dou X at the W control volume. Earlier we have seen for the U control volume. Now on the left hand side, so it is minus dou P by dou X the same thing, triple integral, then it is dx, dy, dz as the operator. When I am going to integrate, it will become minus p. Where is the nodes? Where is the limit of nodes? It starts from capital W and ends at capital P. So W to P, yeah, it become dy will become y and it will become delta y, delta z. So it will become minus pp minus of minus pw. I am trying to apply the limits. So it will become what? Del y, del z is nothing but area, aw. So now its minus or minus will become plus. So pw minus pp of aw, small w. So this is the value of dou p by dou x for the left hand side w control volume. Here we see for the right hand side E control volume. So I will write both this equation so that it will be easy for us to recollect. So it is AE UE equal to sigma of A NB U NB plus B plus PP minus PE of AE. Let it be equation number 2. This is when you are trying to apply for the E control volume. When I am trying to apply for the W control volume on the western side, it will become what? AW UW will be equal to sigma of A NB UNB is corresponding neighboring nodes plus B source term plus it will be PW minus PP of AW. So we can see there is a slight change. Here it is PP minus PW, whereas here it is PW minus PP. So when you are going to move from left to right, only the sign convention will be there. So PP minus PE. Always you are moving from what? Left to right. So it will be PP minus PE. Here it will be what? PW minus PP of AW. So I hope you now know how to get the velocity UE at the E control volume and how to get the velocity UW at the V control volume. Similarly, we can extend this for the N control volume and what? S control volume. Similarly, the top control volume and the bottom control volume. So let us move further. So it will become AN. It will be, I will change the mode. It is AN UN applying to the what northern side. So AN UN will be equal to, here the velocity will not be U, here the velocity will be V. So AN VN equal to sigma of ANB UNB plus B plus it will be PP minus PN of AN. Okay, it will be even better if I can copy the previous one and put it over here so that you can also tell parallelly. Okay, so in order to do that, I will just erase it. In order to make it more comfort for you, just I want to erase this one and I will repeat and write the same two equations what we discussed in the previous slide. Those are nothing but AE UE equal to sigma ANB UNB plus B plus PP minus PE of area AE. So we can see the equation number 2. Yeah, coming over now to the north control volume. So it will become AN, it is V, the velocity is along the y direction is V. So it is AN VN is equal to sigma of ANB VNB plus B plus PP minus PN, because that V control volume has what? The nodes as P and N. So we will end up with what? PP minus PN of AN. This AN and all some area of the corresponding V control volume, that is it. Is some coefficients, some numbers. Now similarly coming to what? It is AT WT, that is I am going to find the velocity along the Z direction. Along the X direction is called as U, along the Y direction is called as V, along the Z direction is called as W. So it is AT WT will be equal to ANB WNB plus B plus it will be PP minus PT of AT, that is the area of the particular control volume. So how to have some idea about these thoughts is nothing but, if I am going to have the x direction, it will be my east and west, it is nothing but my north and south, it is nothing but what, my top and bottom. So along this x direction the velocity is called as u, along this y direction the velocity is called as what, v, along this z direction the velocity is called as what, w, and hence ue, ae, ue, here it is what, an, vn, here it is what, at, wt. I hope now with this diagram it will be easy to recollect this equation. Let us call this equation as 2, and already we have given the equation 3 for some other one, and hence we will call this as 4, this is 5. Now once again I will write this equation from the previous slide, namely it is a w, that is on the left hand side of the u component. So a w u w will be equal to sigma of a n b u n b plus b plus instead of pp minus pe, it is here it is pw minus pp of aw. We have shown how it came also. Let it be equation number 3. Then the next equation will be a, here north means the other side will be southern side in the y direction. So as vs will be equal to sigma of a nb v nb, here also it is v only, okay, so I have tried properly, it is v plus b plus here it will be p south minus pp of a south. So equation number it is 6. Then we can call this as a bottom, w bottom. So already we have a top, wt, here ab, wb will be equal to sigma of, it will be a nb, instead of v will have w, because in the z direction we have the w component of the velocity. So a nb w nb plus b plus pb minus pp of a b. So we are able to arrive the different component of the velocities, namely ue along the x direction, similarly uw on the s component on the x direction on the left hand side face, similarly vn and vs, wt and wb. So these are the expressions. Don't worry about the equation numbers, let it be 2, 3, 4, 5, 6 or whatever the order of the equation is not important, but we know how to arrive at this six equations. Okay, if you from equation number 2, still if you want I can get ue will be equal to what, sigma anb unb plus b by ae plus ae by ae of pp minus pe. This one I obtained from equation number 2. What I did in this equation, I divided all the terms by a small e. Okay, a small e is nothing but some coefficients, some numbers. Okay, so that numbers I divided uniformly for all the terms. So I landed up at ue equal to sigma anb unb plus b, because b is also a constant, by ae plus ae by ae of pp minus pe. And generally this term is given as de in all conventional textbooks, and hence we are also going with this a is area is a constant, this small a is a coefficient, is also a constant. So constant by constant is another constant which we are indicating as d. So de of pp minus pe, and here it will be what, anb unb plus b by ae. This is nothing but my ue. Similarly I can obtain uw, vn, vs, wt as well as what, wb. So I hope you can do at your home and you can able to get all these values. Okay, yeah, so this is the way. So the finally I will try to tell that ae ue is nothing but sigma anb unb plus b plus pp minus pe of ae. This is what we call this equation as equation number 2, applicable to the U control volume at the phase at the east side phase. Okay, so this is the equation. Now if I want to find what is my aim? To find the velocity, where U velocity, where at this particular control volume, at the U control volume, namely on the right hand side, and hence it is called as UE. So the main objective of equation number 2 is to find UE, is to find what? UE. So this UE depends upon the various velocity components which we can get it, but the main driving force for this equation is nothing but the pressure gradient, because the flow will happen only whenever there is a pressure difference. So we are unaware of this PP minus PE. We do not know what is PP, we do not know what is PE. If I know PP and PE, definitely I can get UE, because in the momentum equation the unknown is what? There are once again I will come to the basics. We have U, V, W and P. Here we have U, V, W, but the unknown is what? Only the pressure. So we do not know the pressure. Here also in this equation we can see this pressure term is not known. PP minus PE is not known. If this is known, definitely I can find UE. That is the velocity in the control volume. U control volume, I can find it. I can find UE. So we have to first of all find a PP minus PE. So for that what we can do means we can go for by the iterative method. In this iterative method, what we are going to do is that we are going to assume or guess. It is not even appropriate to call us assume. It is better to call us to guess some values of pressure. To have guessing some values of the pressure. When I am going to guess the pressure, we can call the term as P star. So the star indicates guessed value. Please recall, whenever we have some values which we want to which is not known and we are going to guessing on our own, that is indicated by the star letter. So guessed value, guessed pressure value. So now what will happen means this P will become PP star. Why? Because I do not know PP, so I am going to guess the value of PP, so it is called as PP star. Similarly, PE will become what? PE star. Similarly, P north will become what? P north star. I hope you got it. PS will be called as what? PS star. PT will be called as what? PT star. So I hope you got the logic. P bottom will be called as what? P bottom star. Similarly, P west will be called as what? P west star. So all these values we are going to assume, or not assume, we are going to guess. So it is called as the guessed values. So the pressure values we are guessing it, and hence the corresponding velocity whatever you are going to obtain from these equations will be the guessed velocities. So we are going to assume it is PP star and P star. So whether I get UE? No, I can't get UE. I can get only UE star. So the UE will become UE star. What is UE star? Guessed velocity. The corresponding velocity what we obtained is called as what? Guessed velocity. What will be UW? UW will be called as UW star. What is VN? VN will be called as VN star. What is VS? VS will be called as VS star. I hope you got it. WT will be called as WT star, and WB will be called as WB star. And hence now the equation, when I am going to substitute PP equal to PP star and P equal to P star, I will end up with this equation like this. It will be AE UE star. Why I am putting star? Because I am going to assume, guess the value for the pressure, and hence the velocity will also become guessed value. So it will become A and B. Now the U and B also will become what? All become star. So it is called as U and B star plus B plus PP star minus PE star of AE. Let us call this equation as number, I will go to the previous slide. Already we have given equation up to 7. So let us take this as equation number. I will take this as equation number. I will consider this as equation number 8. So I will copy these two equations and put in the next slide, and we will discuss further. So what is the objective here done here? We try to frame a equation for the U control volume. With that we try to find the equation for UE. AE UE equal to sigma ENB UNB plus B plus PP minus PE of AE. In this equation, if we know the pressure difference, we can find the velocity UE. Since we do not know about the pressure value, we are going to guess it. So it becomes star. So PP will become PP star and so on. I don't want to waste your time. When I am going to substitute for PP as PP star and PE as PE star, then I will end up with UE as what? UE star. So up to here we are there. Now let us move to the next stage. So it is AE UE equal to, I am writing once again the same equations, equal to sigma ANB UNB plus B plus PP minus PE, let it be equation number 2, sorry. Then we ended up with AE UE star equal to sigma ANB UNB star plus B plus PP star minus PE star, equation number 8. So now I am going to subtract equation number 8 from equation number 2. So subtract equation 8 from equation 2. So it becomes AE can be taken common, AE of UE minus UE star is equal to sigma of ANB can be taken common, it will become UNB minus UNB star. This plus B minus plus B will get cancelled because plus B minus B will become 0, plus PP minus PP star minus PE minus PE star of, I have left these terms actually here AE and AE. So here also this term AE will come, let it be equation number 9. So what I did, first I did the generalized equation. Here the U is the correct velocity and the UNB also the correct velocity, but the drawback is that we do not know the pressure difference or the pressure gradient PP minus PE. So we are going to guess the pressure value and hence the values are indicated as star and the corresponding velocity will also be star. That is the second one. So the correct velocity, equation number 2 is the correct velocity, equation number 8 is the guessed velocity, and I am going to subtract the correct velocity to the this one to the guessed velocity. So I got AE of UE minus UE star equal to this much. So this value is the correct value. This is nothing but my guessed value, isn't it? This is the guessed value, that is the correct value of the velocity. If I am going to subtract these two things, I will get the velocity correction. So how much I have to get corrected? I will get the equation for the velocity. So that equation is called as velocity correction equation. It is called as what? Velocity correction equation. Let us indicate the velocity correction by a term called as prime. Earlier we are indicating the term star for guessed value and we are going to use the term prime for the corrected value or velocity correction terms. We are going to use the prime terms. So if I am going to write, you can easily understand AE UE prime. What is UE prime? UE minus UE star is called as UE prime. The correct value of the velocity minus the guessed value will give me the velocity correction. So AE UE prime will be equal to sigma ANB UNB prime plus, can you tell what is the value of PP minus PE star? It is it will be PP prime minus PE prime of AE, because we know that PP is the correct value of the pressure, PP star is the guessed value of the pressure, and hence if I am going to subtract these two things, I will get the pressure correction. So we can say it is PP dash minus PE dash of AE. Okay, so from that if you want the velocity alone, UE prime or the velocity correction for UE is nothing but UE prime will be equal to sigma ANB UNB prime by AE plus this AE by small a is nothing but DE of PP prime minus PE prime. Let us call this equation as equation number 10. So if there is any doubt, it is very simple. First we are writing the equation for the correct velocity. Since we do not know the pressure, we are going to guess it. So the equation, the same equation will end up with the star values everywhere. So if I am going to subtract the correct value with that of the guessed value, I will get how much of correction I have to do for the velocity. Similarly, how much of correction I have to do for the pressure terms. So that the corrections terms I am indicating with the letter prime. So the final expression will become AE UE prime equal to sigma ANB UNB prime plus this BB will get cancelled, and hence we will end up with plus PP prime minus PE prime of your AE. I hope you got it. This AE by AE, yeah, AE. Then if I want to have only the velocity components, then UE prime will be equal to sigma ANB UNB prime by AE plus this capital AE by small a is another constant, is nothing but DE. So DE of PP prime minus PE prime. So let us call this equation as equation number 10. What is this UE prime is called as velocity correction equation. UE prime is called as what? Velocity correction equation. Let us move further. So it is UE prime is equal to sigma ANB UNB prime by AE plus DE of PP prime minus PE prime. Let us take it as equation number 10. What will be Vn prime? Vn prime will be, can you tell me what is Vn prime? Can you try it? Yeah, it is ANB VNB prime by AN plus DN of PP prime minus PN prime. So this is the velocity correction equation along the y direction, that is Vn prime. So let us call this equation as equation number 11. Similarly, let us try to write the velocity correction equation for the z direction, which is nothing but Wt dash will be equal to sigma of ANB WNB prime by AT plus DT of PP dash minus PT dash. Let us call this equation number 12. So these are on the right hand side, the top side, on the top side. Similarly, I can write on the left hand side, bottom side, as well as the southern side. So let us try to write those equations also, which are nothing but W E prime, that is the velocity along the x direction, but the left hand side will be equal to sigma ANB UNB prime by, instead of AE it is AW, okay, plus DW, but what is the thing, you should not put PP dash minus PW dash, you have to put PW dash minus PP dash, okay. So it will become PW dash minus PP dash. Let us call this as equation number 13. We have already explained the reason, so I don't want to repeat it. Then let us take it as I am sorry, it should not be W, I am really sorry, it is not W. What should be? It should be U. U, instead of E it should be what? It should be W. So UW dash is equal to sigma ANB UNB dash by AW plus DW of PW dash minus PP dash. Now let us try to first have the term, it is velocity vector V only, but not in the northern side but in the southern side. So it is WS prime will be equal to sigma of ANB WNB prime by AS plus DS of PS dash minus PP dash. I hope it is more clear now. Let us move on to the last one. It is nothing but what? The W component of velocity, but not in the top side but in the bottom side. So it is WB dash will be equal to sigma of ANB WNB prime by AB plus DB of PB dash minus PP dash. Let it be equation number 15. So now you got the equations for the velocity corrections of the velocity along the x directions, y direction as well as the z direction in both right and left, front and back, top and bottom. So we got these 6 equations. Whether our problem is solved. Now my question is whether our problem is solved. What is our problem? Our problem is to find u, v, w and p from the momentum equation. We have only 3 equations, but there are 4 unknowns. Now initially we have the correct velocity, we have got an equation, then we do not know the pressure values, so we guess the pressure values, so we written another equation with a star. Then what we did, we tried to subtract these 2 equations so that we will get the velocity correction. From the velocity correction we got the various velocity components for the velocity correction, namely ue prime, then vn prime, wt prime, similarly uw prime, vs prime and wp prime. So when we got all this equation, still my question is whether we will be able to obtain ue prime, vn prime means still it is not possible. Why it is not still possible? Because still we do not know the value of pp dash and pe dash. So only the form is changed. Initially we guessed and we subtracted, still the values of this pp dash and pe dash are still unknown. So let us move further. I will take the equation number 10 alone and I will try to explain the concept further. All these equations are one and the similar. If I am able to write 10, then you can easily write equation number 11, 12 up to 15. Okay. Now let me take the equation number 10. The equation number 10 is nothing but ue prime is equal to sigma anb unb prime by ae plus pp prime minus pe prime of de. Let it be equation number 10. Let us try to explore what does this equation is about to communicate to us, or what is the inference we got from this equation. That is, the velocity correction at a particular node or the phase is obtained by the velocity correction of the neighboring nodes. So what is this unb prime? That is the velocity correction of the neighboring nodes plus the pressure correction. I will repeat once again. If you want to get the velocity correction at a particular phase or a particular control volume, then it should be obtained by the velocity correction of the neighboring nodes. That is nothing but what? unb prime plus the pressure correction, But what I am going to do is that I am going to purposefully make this first term to be 0. Then you will tell it is not okay because it is not satisfying. The idea is that if earlier this x equal to y plus z, let us take this ue prime as x and this term as y and this term as z. Earlier let us say this total value is 100 and this value is contributed by y is, say, for example I am telling, for your understanding I am telling, so y is 30 and z is what? 70. The contribution of the velocity correction by the neighboring nodes contribute to 30% and the contribution by the pressure term is, say, 70%. Now this velocity correction fellow in the neighboring nodes, they are not helping, they already made it to 0, but still this equation can be balanced. How? Now the pressure correction has to do more work, that is this 70 should become what? 100, then this equation is valid, that is, if I am giving a job to be done by 2 students and out of this job the student, let us say the 2 students are A and B. A is contributing to 30% and B is contributing to 70%. Unfortunately this fellow A could not turn up, but any other work should be submitted to me. So the student B takes the entire load of 100% and completes the work and give to me. So this is the concept. So the idea is very clear now. Now what you are doing, when you are making the velocity correction of the neighboring nodes to be 0, you are overburdening the pressure correction term. You are giving more load to the pressure correction term. This particular phenomenon is called as overburdening of pressure correction. So I hope you got the meaning of Why it is called as overburdening of pressure correction terms. So this is called as overburdening. When I make it 0, it is called as overburdening. But there is an advantage also. We will try to come to that point later. So we got the physical meaning of this equation as the velocity correction at a particular control volume depends upon the velocity correction of the nearby nodes plus the pressure correction. But purposefully I am making the velocity correction of the neighboring nodes to be 0, so that I am loading more on the pressure correction, but still is okay, and hence this is called as what? Overburdening of the pressure correction. So finally I will end up with now UE prime is equal to what? dE of PP prime minus PE prime. PP prime minus PE prime. Similarly, what will be Vn prime? So this Vn prime will be equal to dN of PP prime minus Pn prime. What will be Wt prime? It will be dt of PP prime minus Pt prime. What will be Uw prime? It will be dW of, instead of PP prime minus P prime, here it will be Pw prime minus Pp prime, and here it will be Vs prime will be equal to ds of Ps prime minus Pp prime. Similarly, it will be W small b prime will be equal to dB of Pb prime minus Pp prime. So let us call this equations 16, 17, 18, 19, 20 and 21. So we got the expressions for the velocity correction in terms of pressure correction alone. In terms of what? Pressure correction alone. Got the logic? So earlier we have the velocity correction depends upon the velocity correction of the neighboring nodes plus the pressure correction. Now we have purposely removed the velocity correction of the neighboring nodes and we are overburdening the pressure correction. Finally we ended with like this expressions for the velocity corrections of the various control volumes, namely the U control volume, V control volume and W control volume on the eastern side as well as in the western side. Let us move further. Still the question is not solved. Why it is not solved? Because still we do not know the value of Pp dash and Pe dash, but we want to find the value of Ue dash. Okay. Now we earlier know that what we earlier know that Ue minus Ue star is equal to what? Ue prime. That is the correct value of the velocity minus the guessed value of the velocity will give me the velocity correction. From this what I can get is nothing but Ue will be equal to Ue prime plus Ue dash. This Ue value is the new Ue value, that is for the second iteration this will be the Ue value. Got the logic what I am telling? First initially I am having the Ue is the correct velocity which we do not know, then which we do not know, then we are trying to assume certain value of the pressure, we are getting Ue star, then I am going to subtract these two equations, I will get Ue prime. So now Ue minus Ue star equal to Ue prime, which means Ue will be equal to Ue star plus Ue prime. So already we know Ue is what, nothing but what? Ue star. And what is Ue prime? Ue prime is nothing but dE of Pp star minus Pe star. I hope I am right. Yeah, dE of Pp prime minus Pe prime. Pp prime minus Pe prime. So now I got the refined value of Ue. Similarly, I don't want to bore you, just you can write it for UW. Just you can write for UW will be equal to UW star plus dE of P W prime minus Pp prime. Similarly, Vn will be equal to Vn star plus dN of Pp prime minus Pn prime. Similarly, V small s will be equal to Vs star plus ds of Ps star Ps prime minus Pp prime. then WT will be equal to WT star plus dW of PP star minus PT prime. Sorry, somewhere I will be using instead of prime I will be telling a star, but I hope we can get it. WB will be equal to WB star plus dB of PB prime minus PP prime. So let us call this equation as 22. From 20 we can call this as, from whatever the expression is not an issue, we can give any number of equation. So let it be 22, 23, 24. Still this million dollar question is not solved still so far. What is that? I want to find UE, UW, VN, VS, WT, WP. Out of this I know UE star, UW star, VN star, VS star, WT star and WP star, because these are the guessed values of the velocity which I arrived from the guessed value of the pressure. But still I do not know the values on the right hand side, namely the pressure correction terms I do not know. These are the pressure correction terms which we do not know the answer. So how we are going to solve this particular terms, especially these values, how we are going to get these values? If I know these values, then automatically my problem is solved. I can find the velocities for this UE, UW, VN, VS, etc. So let us move further. For this, definitely we had to make use of the continuity equation. Let us make use of the continuity equation. I can tell you in a very simple terms like this. First, you assume certain value of pressure for your U momentum, V momentum, W momentum. Try to get the, so now the unknowns are what? 3 unknowns, U, V and W, because the pressure we have guessed. So definitely we will get U star, V star and W star, some guessed value of the velocity. You try to substitute this value of U star, V star, W star in our continuity equation. Okay, I am telling as a logic only. So when you are going to try to get the values whatever you get for the U, V, W from the momentum equation, you try to substitute the continuity equation. If this continuity equation is become 0, then it satisfies the continuity equation, which means that our assumed value of pressure is right, so that our assumed velocity value is also right, and hence the continuity equation becomes 0. But most probably it will not become, the continuity equation we are going to substitute for this velocities will not become 0. So we have to do the pressure correction, then we have to do the velocity correction, then you have to update the velocity, then once again you try to substitute in the continuity equation. If this in this continuity equation, if it is going to be 0, then it is pakka, we have obtained the convergence. If it is not there, once again you go for the corrections until the correction becomes 0. So I have explained, but partially you may understood, but if I am going to go through the process, definitely you will be able to appreciate how we are doing it. So definitely we need the help of the continuity equation. That is what I am about to tell. Okay, in the momentum equation we have the U, V, W and P. We are going to assume P, so we will get U, V, W. Try to take this U, V, W and substitute in the continuity equation. If it is going to be 0, then our assumed pressure is right. But most of the cases it will not be equal to 0. So we have to do for the pressure correction, velocity corrections. Then once again you get the new values of the velocities. Try to substitute in the continuity equation. If it is going to be 0, then we are converged. If it is not 0, once again do this iterative process until the value whatever I am going to substitute for U, V, W will satisfy my continuity equation. So the idea is that definitely we need the help of the continuity equation. Now let us write the continuity equation. So what is the continuity equation? Dou rho by dou t plus dou by dou x of rho u plus dou by dou y of rho v plus dou by dou z of rho w is equal to 0. This is my continuity equation. Here I am going to substitute for UE, UW, VN, VS, WT and WB. I am going to see, I am going to substitute. And if this value is going to come to be 0, then my values are right. If it is not equal to 0, I have to go for the iteration. Since this continuity equation is there, the continuity equation is meant for what? It is concerned for the conservation of mass. It is a scalar equation. So which control volume I have to take? Whether I have to take the U control volume or V control volume or the main control volume? I will repeat the question. Now this kinetic equation is nothing but the conservation of, is based on the principle of conservation of mass. Mass is a scalar quantity, and hence my question is, we have three control volumes. The three control volumes are U control volume, V control volume, and what? The main control volume. If you want, you can have W control volume also, because the velocity control volume. Okay, fine. So we have four control volumes: U control volume, V control volume, W control volume. These are for the velocities. And one more control volume is there, is called the main control volume. That main control volume is for the scalar. So since the kinetic equation is scalar quantity, we are going for the main control volume or the P control volume or the P control volume. I want to recall that. So here the control volume is differing from the U control volume. Here the control volume is the main control volume. So if you want to draw, I can tell this is my P, this is my E, this is my western node. So this is my E west, and hence my control volume will be from here to here only. Got it? E W. This is my main control volume. I am going to apply this governing equation to the main control volume only. I am not going to apply to the E control volume or V control volume or W control volume. I am going to apply only for the main control volume. This control volume is called either P control volume or the main control volume or the scalar control volume. I hope you got it. Okay. Why I keep on telling this point is that you should apply the limits very carefully. You should not apply the limits wrongly. We have to apply the limits more correctly. Okay. Now we are going to integrate this equation with respect to this control volume, with respect to space as well as with respect to time, because we are considering a more generic case. The more generic case is that it can be transient as well as it can be for all the three dimensions. So we are going to have four integrals. One is for the time derivative and other three are for the spatial derivatives. I will write now. So it will become four integrals. The first integral is for time, t equal to t and t equal to t plus delta t, and it will become dou rho by dou t of dt. The second integral for the x direction, so it will move from small w to small e. You got it? Why I have drawn this control volume? Here it starts from W and ends at E. Small w to small e. That is also very important. Whether you are moving from node to node or from face to face. Here I am moving from W to small e. Okay. Similarly, on the y direction, it will be southern face to the northern face. Similarly, in the z direction, it will be bottom face to the top face. And hence the corresponding operators are dx, dy and dz. I hope you got it. So I am going to integrate all the terms with respect to both the time and spatial derivatives. The time is varying between t equal to t and t equal to t plus delta t. And coming to the x direction, the limits of integrations are from small w to small e. In the y direction it is small s to small n, and in the z direction it is from small b to small t. I hope it is, you are able to follow me. Yeah. Now the second term will become like this. Since they are going to be complete integral, there is nothing wrong whether you are going to do the time integral first, then the spatial integral, or first you are going to do the spatial integral and the time integral. Nothing wrong in that. You can do in either way. All will end up in the same results. So here I am going to do, I am going to take the time integral of the last t equal to t plus delta t. Then it will be western to eastern, southern to northern, bottom to top of dou by dou x of rho u of dx, dy, dz. So this is for this one and this is for this one, and we have to write for the next two terms. I will write it fastly. So plus 4 integrals, it is t equal to t plus delta t, b to t, here it will be south to north, western face to eastern face, dou by dou x of dou y of rho v into dx, dy, dz and dt. Here I missed the term dt, I am adding now, plus the last term. The last term will also be the having the 4 integrals. So t equal to t plus delta t, bottom to top, southern to northern, western to eastern, dou by dou z of rho w of dx, dy, dz equal to 0. So this coordinate equation I am trying to apply this Gaussian equation of coordinate equation to this particular control volume. Here I have showed only one dimensional, but I hope you can imagine for two dimensional as well as for the three dimensional like this. It is my east west, it is my north south, this is my top bottom. So based on this three dimensional we have arrived for this equation. I need to copy this equation once again. I will move to the next slide and I will try to explain further. I will make it fast. It is a fourth integral. It is t equal to t plus delta t, western to eastern, southern to northern, then it will be bottom to top of dou rho by dou t of dt dx dy dz plus, I hope you know the integral limits. So it is dou rho u by dou x of dx dy dz dt. So I am writing here t plus delta t. I hope you can assume the other integral values, limits, plus once again I am going to write all the four things. T equal to t plus delta t, dou by dou y of rho v of dx dy dz into dt, plus one more term, I hope you can write on your own, dou by dou z of rho w of dx dy dz dt equal to 0. So this is nothing but t equal to t plus delta t. So now let us come to the first term and try to integrate with respect to time. So dou rho by dou t, when I am going to have dou rho by dou t is a first order derivative, when I am going to integrate, dou rho by dou t will become rho. Similarly we have seen earlier, minus dou p by dou x of dx will become minus p. Similarly dou rho by dou t of dt will become rho. So now it become, when I am going to integrate dou rho by dou t it will become rho, but what is the time of integral of time limits? For the time limits t equal to t plus delta t, because I have to apply the limits, because I am integrating with respect to time derivative. Okay, so it is t to t plus delta t. Let us assume here we are trying to find the density at which location, at either p or small e. It is a scalar quantity, we are trying to find at the location called as p. Even if you want I can show the, you can see I am trying to find the value at a small p, capital P. So I want to find the value at p. So we can see here the value of density at time t is known, at time t plus delta t is unknown. That is the meaning generally. At time t equal to 0 means it is a known value, it is an initial condition. After certain time, say 1 second or 2 seconds or some microseconds or whatever may be there, after some delta t, we do not know the value. So generally for the known one we will put as not, for the unknown one we will put without not. I will explain you now. I will write, you can understand. So this value will become what? Rho p minus rho naught p. What is here rho p and rho naught p? Rho p is the density at the point p after the time t plus delta t, or at the time t plus delta t, and rho naught p is the density at the time t. Here out of these two variables, which is known to you? This value is known to you, because this is the density corresponding to the time t equal to t, that is known to us, whereas the density at time t plus delta t is unknown to us. It is called what? Rho p. That is what I told. A notation with not indicates known value and a notation without not indicates unknown value. So this is, the first term is unknown, the second term is known. Both you are finding the density at the same point p only, but after certain time. I hope you got it. So I have integrated rho with respect to the time, and it become what? Dx, you know, it become x. The limit of integration is 0 to delta x. So applying the upper limit minus lower limit, it will become delta x. Similarly, dy will become delta y, dz will become, dy will become delta y, and dz will become delta z. If you want I can explain. If I am going to integrate dx, the value will become x only. But what is the limit? 0 to delta x. So it is delta x minus 0, which is nothing but delta x. So this is the way how we have ended up with delta x here. It's very basic, but even then I want to make it more clearer. So just for your information I have written, so I am erasing this one. Plus, let us come to integrate the second term. Here it is with respect to the space, namely the dx. So I am going to integrate dou by dou x of rho u with respect to dx. So instead of here p or rho, we have rho u. So this is the first order derivative. So when I am going to integrate, this derivative will go away. So the answer will be rho u. So the answer will be what? Rho u. When I am going to integrate dou by dou x of rho u into dx, the answer will be rho u. From where are the limits? The limits is very important. So that only I have drawn the control volume. You can see the limits are from western phase to the eastern phase in the x direction. So already we have written here. Yeah, I have not written. So it should be what? It should be what? Western to eastern. Yeah, I have written here. It will be southern to northern and bottom to top. So it will be from western phase to the eastern phase. As I explained to you earlier, dy will become delta y, dz will become delta z, dt will become delta t. dt will become what? Once again, dt will become t. The limits of integrations are t to t plus delta t. When I am subtracting, I will end up with what? Delta t. I hope you got the idea how we have integrated the second term. Similarly, if I can integrate the third and fourth term, I will end up like this, plus rho into v of the limits of integration of the y direction are southern phase to the northern phase. It will become delta x delta z into delta t, because this particular term, when I am going to integrate, I have to integrate like this, dou by dou of rho v into dy, that term will become what? Rho v. So the dx will become what? Delta x, dz will become delta z, dt will become delta t. I hope you got it. Plus the last term, it will be rho w, rho w, the limits of integration are from bottom to top. It will be delta x delta y into delta t is equal to 0. So after integrating this equation, I am going to divide this entire equation by delta t. Please listen here. I obtained the equation after integrating. After getting this value, I don't want to just copy once again this equation to the next slide. So I want to overcome that hurdle. What I am going to do here is that I am going to divide each term by delta t. So this term also I am dividing by delta t. This term also I am dividing by delta t. This term also I am dividing by delta t. This term also I am dividing by delta t. So there is no change in the first term. The second term, what will happen? Delta t by delta t becomes 1. This also become 1. This also become 1. So let me try to take it to the next slide and try to even I am going to apply the limits. What are the limits? It is rho e ue minus rho w uw. Here it will be what? Rho n vn minus rho s vs. Here it will be rho t wt minus rho b wb. So we will do some mathematical work and we will try to simplify it. Now it is more of mathematics. The physics is almost done. So it will be rho p minus rho naught p of del x del y del z by del t. This is the first term. The second term will be applying the limits of integration rho e ue minus rho w uw of del y del z plus rho n vn minus rho s vs of del x into del z. The very simple concept is it is related to the dx term or the first dou by dou x of rho u. So that term will not have del x. This term is with respect to y direction, so del y will not come. So we can rewrite the other two terms plus rho w, it is not rho w, what this term is called as rho t wt minus rho b. The limits of integrations are from b to t. So it is rho b wb. Here it is all the z action. So which term should not come? Delta z should not come. So we will end up with delta x and delta y. Delta x and delta y equal 0. So we are able to follow this one. But how we are going to link the pressure term to the kinetic equation? That is the beauty here. So we are at this stage now. We are going to relate the pressure term what we obtained earlier from the momentum equation to here. To this equation is called as what? Kinetic equation. So what are the values we got already? We will go little back and try to get those values and try to substitute for which one? UE, UW. I am going to substitute for UE, UW, VN, VS, WT and WB from the momentum equation. What is this equation is called as? Kinetic equation. That what I told. What are the value you got it from the momentum equation, you try to come and substitute in this kinetic equation. If this is going to get satisfied, your task is over. Mostly it will not get satisfied. You have to go for some iterations. Now let us try to take the values from the momentum equation and try to substitute over here in the kinetic equation. Let us go back and see what are the values. So you can see here I have the values of UE, UW, VN, VS, WT and WP. So substitute the values of this one from equation number 22 to 27 in the latest equation 28. What is the equation number? This equation we can call this equation as what? We can call this equation as 28. So substitute the values of UE, UW, VN, VS, WT and WB from equations 22 to 27 to equation number 28. So I will simply write like this here, substitute 22 to 27 in equation 28. Got it? Okay. So let us further continue on. Rho p minus rho naught p of del x, del y, del z by del t plus rho e. What is UE? I am going to get it from there. So it is UE is nothing but UE star plus dE of PP prime minus PE prime. Okay, I hope you got it. Of not I should not put a bigger bracket here, minus what is this? UW, rho W. UW is nothing but UW star plus DW into, it should be the other way, PW dash, we should be very careful, into PP dash whole bracket of del y del z. So I have substituted the value of UE and UW from the momentum equation to this kinetic equation, as like this. Okay, good. I hope you got it. Plus rho n. What is Vn? Vn is nothing but Vn star plus Dn of Pp prime minus Pn prime minus rho s of Us star plus ds of ps dash minus pp dash of, it is in the y direction, so delta y should not come, so it is of delta x into delta z. If I want to write the third term, it will be, I am going to substitute here, it is rho t. What is Wt? Wt is nothing but Wt star plus dt of pp star minus pt star, sorry, it's not star, it's prime, I hope you got it, minus rho b of, what is Wb? Wb is nothing but Wb star plus db of pb prime minus pp dash or prime into, is a z direction, so only delta x and delta y will come, so delta x delta y is equal to 0. Almost we are done. Be patient, we are going to complete in another 5 minutes, nothing to worry. So it's fully mathematical. When I am explaining, I am taking more amount of time, but if you want to recall it, you can do it very easily. Okay, So we can see the continuity equation. We are trying to replace the values of UE, UW, Vn, Vs and Wt and Wp from the momentum equation, and we got the equation like this. This equation is called as what? Continuity equation. This equation I may also call, or I should also call, as pressure correction equation. This equation is only called as what? Pressure correction equation. What about that UE prime, UW prime, Vn prime, Vs prime, Wt prime and Wp prime? They are called as velocity correction equation. Whereas this continuity equation, now when you substitute the value here, becomes the pressure correction equation. This equation is called as what? Pressure correction equation, because from this equation only we are going to correct the value of pressure. We are going to correct the value of pressure. Now this much of big equation is there, this much of bigger equation is there, but I am going to write the final form like this. I am going to write the final form of this as, what is our objective in this equation? What you are going to find out in this equation? Now what you are going to find out? Whether you know UE star? Yes, we know UE star. Why? Because that is the gust velocity. Based on the gust pressure, we obtained the UE star. So that the value is known. Similarly, what are the terms with star are known values. What about rho p and rho naught p? They are known values. Why is the known values? Because it is incompressible. The density will not change. So the density is also known. Delta x, delta y, delta z known, because you are going to choose the coordinates, your mesh, your dimension of the control volume, you know that. You also know about delta t, the time step, you are going to decide on that. So delta t is also known. Then dE is going to be a constant, that is also known. So now the only variable in this equation is pp prime or pp dash. The only variable is what? Pp prime. Once you know pp prime, it is easy to find a pe prime, pw prime, pn prime, wherever the terms with prime is unknown from this equation, So how many equations, how many unknown? There is only one equation with one unknown. There is only one equation with one unknown. Here the unknown is what? Pp prime. The only unknown in this equation is what? Pp prime. Once you find Pp prime, you move the node from P to E. Now the node E becomes P. So once again find the value. So you will get the values for each and every node, the pressure at each and every node. I hope you got it. So so from this equation, the only unknown is Pp prime. So we have one equation and one unknown. So it is possible to solve this equation and to get the value of Pp prime. To get the value of Pp prime. That's what I am going to do it. Let us move further. So this equation can be written as AP Pp prime is equal to AE PE prime plus AW PW prime plus A north PN prime plus A south PS prime plus AT PT prime plus AB PP prime plus the constant. Like this equation we have seen somewhere by the beginning of this class. Shall we go further? I told you I will explain how this equation came at the end of the session today, like that. So I am going once again back to the earlier version. So here I written like this. Here the unknown is UE, whereas in the continuity equation the unknown is Pp dash. Here the unknown is what? AE. There I written AE UE equal to the AE UE, the corresponding neighboring nodes of this small e. So I have written all the nodes and a what? And a source term B. Plus I have written a pressure difference term also there in the continuity equation, sorry, in the U momentum equation. But in the continuity equation there is no pressure gradient term, and hence I have ended up with a similar equation like this. But there also I have not given the reason, here also I have not given the reason, but I am still writing as what? APPP dash equal to AEP dash plus AWPW dash. A similar equation I am writing, that's what I can tell you. I am writing a similar equation what we have started during today's session, and similar equation I have written here along with B, but there is no term related to dou p by dou x because the continuity equation doesn't have dou p by dou x. Okay, fine. Now I will explain how we got this equation. Now let us try to obtain what is AE. What is AE? What is AE? The coefficient of PE prime. What is AE? The terms which are before PE prime, they are nothing but what? AE. So let us go to the previous equation. You see here, where is PE prime? PE prime, I will mark by red color. So PE prime is here. So what are terms which are before this PE prime? You see here, rho E is there. This rho E, I have to multiply with the DE. So rho E DE minus of rho E DE PE prime into delta y delta z. Don't forget to multiply by delta y delta z. Most of the students forget about this delta y delta z. So the terms which are before this PE are nothing but minus rho E DE PE prime into what? Delta y delta z. Okay. So it is on the left hand side. When I am going to take on to the right hand side, this minus sign will become plus sign. So it become rho E DE PE prime into delta y delta z. Okay, I hope you got it. So this equation when I am going to take in the other side, it become rho E UE, then delta y delta z, then PE prime. Now what is AE? I told the coefficients before what? PE prime. So this is nothing but what? Rho E UE delta y and delta z, not UE, I am sorry, DE. I written wrongly. So it is rho E DE. Why I have not written U means U is not a constant, it is going to be variable. So here we can see rho E DE delta y delta z PE. So what is meant by AE? The coefficients before PE prime. So it will become rho E DE delta y delta z. Any doubt how I got the value of AE? I hope you got it. So AE will be equal to rho E DE delta y delta z. It is going to be a number because density is constant, D is a constant, delta y delta z is also a constant. So it is going to be a number, some coefficient. Okay. Similarly, can you tell me what is AW? There is no need to go to the previous page and try to derive the value of AW. You can tell me now. Yes. Yeah, very good. It is rho W dW into what? Delta y delta z. Just you replace where are the questions with subscript E with W. What about will be AN? AN is the y direction. So it should be what? Delta x and delta z. Delta y should not come. So here will be what? Rho n into dn. What about AS? Still A is in the y direction. So delta y should not come. So delta x delta z. So it will become rho s into ds. What about A top? A top will be equal to rho t dt. Rho t dt of is in the z direction. So delta z should not come. So delta x delta y. What is A bottom? Equal to rho b db of delta x delta y, delta x and delta y. So now we know AE, AW, AN, AS, AT and AB. Yeah, all these terms we know. Okay, now let us move to the previous slide. Let us try to take this term, the first term, rho p minus rho naught p delta x delta y delta z delta t. This is positive, and I am going to take it to become negative, or I can write in the other way. Okay, okay. So now I will try to write what is b. B is nothing but rho naught p minus rho p. Why? If this is negative means we are going to take it to the other side, rho p will become negative. So here rho p is negative. Rho naught p is there is negative, become positive. I hope you got it. Into rho naught p into delta x, delta y, delta z by delta t plus this is the source term. Okay, so this term is just taken to the other side, which is just like a constant. Okay, here every term is known to us, and what are the other terms we can see here? Rho e, u e star, del y, del z. I will write once again in this pink color. So rho e, sorry, it is not coming in pink. Yeah, rho e, u e star into what? Del y, del z. This is what? Positive. When I am going to take it to the other side, become what? Negative. You see here this minus rho w, u w star, del y, del z. This is negative. When I am going to take it to the other side, it become what? Positive. Here whether u w star and u e star are known or unknown. Whether it is known or unknown? Yes, it is known value. Why it is known value? Because we guessed the pressure, we got the guessed velocity. So this is star is also known. The only unknown is prime for the velocity. So these are only the known values. So they are nothing but some numbers. Okay, so I can take these values to the right hand side. So the term which is negative will become positive. The term which is positive will become negative. So I can write like this here, plus rho w u w star minus into what? This del y del z minus rho e u e star into del y del z. Out of these two terms, which is common? Del y del z is common, so we can take it common. So I am going to take this term as common. Which one? Del y del z as common term, and hence it becomes like this. Yeah, it becomes like this. Rho w u w star minus rho e u e star into del y del z. So what will be the corresponding terms for the y direction and z direction? You can see here now. I will show it in this light blue color. Rho n v n star into del x del z. Similarly, minus rho s u s star into del x del z. So this minus rho s u s will become plus, and this plus will become minus. So I will go to the next slide, and I hope now you can easily get it the point. Plus rho s u s star minus rho n, it is not u, it is v. It is v s star minus, otherwise I will erase it and write clearly. So it is rho s v s star minus rho n v n star of, here is y direction. So del x and del z should come. So del x del z plus, can you tell me for the last term in the z direction, similar terms? It will become what? Rho b w, here the last component is w. So w b star minus rho t w t star of del is in the z direction. So z should not come. So it is del x del y. So this is nothing but my b. So if I go to the previous slide, I can tell using the green color, I have made use of this rho t w t star into del y del z. As one term is positive and I am going to take it to the other side, become negative, and minus rho b w b star when it is negative and I am going to take it to the other side, become positive. So now my question is, what is the term which is left alone here? Can you see this equation? This term is also already taken care. This term is also already taken to the right hand side. So almost all terms are taken. Which is the only one term which is left in the left hand side? Yeah, it is pp dash. It is only the terms related to with what? Pp dash. Okay, so what is that Pp dash? Rho E dE. Then this also become what? Plus only, plus rho W dW, because why it become plus? Minus into minus will become plus. So it's rho W dW of Pp dash. Otherwise I will write like this in the next page. It will be rho E, I am sorry, it is rho E dE of Pp dash. Then after Pp dash we have to multiply by, don't forget to multiply with what? Del y del z. Del y del z is common to all the terms. So del y del z should come into del into del y del z. So what is this term? This term is nothing but your AE. So now I can tell this AP is nothing but, if I am going to take all the terms, AP will be nothing but AE plus AW plus AN plus A south plus A top plus A bottom plus AB. I have written only for AE now. If I go to the previous slide, I can tell what will be, this term will become what? AW. Okay, this is rho W, UW into del y del z, minus into minus will become plus. So this is nothing but what? My AW. So here I will get AW, here I will get AN, here I will get AS, here I will get what? AT, here I will get what? AB. All the terms have what? Pp dash as common term. So you take common term as Pp dash, and within the bracket it will become what? AE plus AW plus AN plus what? A south plus A top plus A bottom. So that only I am telling, all these terms once again going to be constant. So you call this constant as AP. AP is nothing but what? AE, AW, AN, AS, AT and AB. So now I am able to convert this form of governing equation into what? This type of discretized form. This only I told in the beginning of the class. I will explain how we have arrived at it, how we are able to convert the differential form of the equation into discretized form using finite volume method. The same approach if you are going to apply there for U momentum, you will be able to appreciate now how we got that equation. I hope in the beginning of the class, AE UE equal to sigma ENB UNB plus B plus one more term, that is because of the pressure term, that is not required here. Okay, so ultimately from this slide, from this page, what you got it, you will be able to get the value of Pp dash. Ultimately, we will end up with the value of what? Pp dash. Okay, good. So now you got the value of Pp dash. You add this Pp dash with the Pp star, because Pp star is guessed pressure. This is nothing but my P nu. With this P nu value, once again go for the iteration. You try to find U, U, W, UE, UW, VN, VS, WT, WP. Go to the, try to substitute once again in the continuity equation. You see whether this equation is getting balanced equal to 0. If it's equal to 0, then this pressure P nu is the final pressure. If it's not equal to 0, once again you go for the iteration until what? Your Pp dash should be 0. Your Pp dash should be 0. There should not be furthermore pressure correction. Then the final pressure is nothing but the pressure on the right hand side. So when this Pp dash will become 0, there is more beauty. So when this Pp dash will become 0, so you can see here this term B is nothing but the source term. Here the first term indicates what is the last two means, we will complete it. So what does this term indicates is that you can see here this is density difference into volume. So density into volume is what? Density equal to mass by volume. So density into volume is the mass by time. So it's nothing but the rate of change of mass inside the control volume. This term indicates the rate of change of mass inside the control volume. Here you can see rho W UW into delta Y delta Z is nothing but what? Rho UA, okay, or rho AV. So the rho AV is nothing but the flow rate along the x direction, or I can tell this term indicates the net amount of mass flow rate along the x direction, in and out of the x direction. This term indicate the net mass flow rate of mass along the y direction. This term indicates what? The net amount of mass flow rate along the z direction. So if the B term becomes 0, which means the mass is conserved, and hence the kinetic equation can be an equation for obtaining the pressure correction. It should also be satisfied. So you have to do this iteration in such a way, when your B becomes 0, automatically your PP dash will also become 0. When your PP dash is going to be 0, there is no need to go for the next iteration. That the pressure prior to this step is the correct pressure, and the corresponding velocities are known as the correct velocities. You have ended up with the iteration. So this technique is called as simple algorithm or semi-implicit pressure linked equation. Why this is called as semi-implicit? Still I have not told the reason. The reason is that I will end up with that also. I don't want to miss that point also. I have written somewhere overburdening. Yeah, you can see here. Now the velocity, I will tell the physical significance once again. Here the velocity correction at a particular node or a phase is depending upon the velocity correction at the neighboring nodes plus the pressure correction at the neighboring nodes. He can see here, since both are implicit, here the velocity correction depends, the velocity correction at a particular phase or node depends upon the velocity correction of the neighboring nodes, which is also implicit, and this is also implement. This is also what? Implicit. Since I am dropping this term, it becomes semi-implicit. If this term is also there, the complexity of fully implicit will be more. So in order to overcome that complexity, we are dropping this term purposely to make it as semi-implicit. So this is why it is called as semi-implicit pressure linked equation. This semi-implicit doesn't have any relationship with time derivative. As we defined earlier for a time derivative like explicit method, implicit method, there we will tell with respect to the time derivatives, or semi-implicit method or Crank-Nicolson scheme, those are with the time derivatives. But here the meaning of semi-implicit doesn't have anything with the time derivative. Here it is called a semi-implicit because earlier the velocity correction at a particular thing depends upon the velocity correction of the neighboring nodes and the pressure correction, implicit pressure correction of the neighboring nodes. Since we are dropping the velocity correction of the neighboring nodes, the fully implicit becomes semi-implicit, and hence it is called as semi-implicit pressure linked equations. So I hope I made it clear. If you have any doubts or query, you are always welcome to mail me at thundil.rajagopal@vat.ac.in. Thank you for your patience listening. Thank you very much.